How to distinguish between gallium arsenide and fluorescent optical fiber temperature sensors.
There are three ways to tell. One is to see sensor lighting effect. Two is to see demodulator excitation light size. Sensor banding performance. Let's compare. The sensors used here are typical of Shenzhen Acova TMEAS technology called limited typical. Fluorescent sensor with fiber diameter of 330 m and gallium arsenide sensor with fiber diameter of 125 m. The corresponding optical mode field are 300 m and 60.5 m respectively. First, look at the sensor lighting effect contrast. Prepare a red light pen, respectively at the sensor light interface irradiation. Observe the size of the light spot coming out of the sensor probe band. For more visual display, I prepare a tool, but also can use a laser pointer instead. Comparing the luminous effects of two sensors simultaneously, you can see the light point at the probe end of the fluorescent sensor is relatively large. Gallium arsenide sensor tip light spot is relatively small, to be seen carefully. Reduce the indoor brightness. You can see clearly the difference is obvious. Then look at the demodulator excitation light comparison. Different sensor demodulators. The excitation light is different after starting. You can see the fluorescent sensor emits a large and bright purple light and multiple channels light up simultaneously, flashing rapidly. Gallium arsenide sensor excitation light is small and light yellow, and multi-channel will slowly patrol light up. The same to be seen carefully. The difference between the two is also very obvious. Finally, look at the comparison of bending resistance. Generally, gallium arsenide sensors have better bending resistance than fluorescent sensors. I will use a regular neutral pen to wind into types of sensor optical cables simultaneously. Observe their bending resistance and temperature changes. The bending radius of the neutral pen is about 10, and it can also be replaced by other column objects. Generally, the better the bending resistance, the smaller the impact on temperature. When winding, it should be noted that it is necessary to wrap several circles closely along the front of the object, rather than loosely and simply wrap several circles, otherwise it will affect the test effect. In order to make the test data more obvious, I have already placed types of sensor probes into the already set 40 degrees Celsius dry well furnace in advance. If there are none, they can be directly placed in the air without affecting the judgment. After winding, it can be found fluorescent sensors with severe temperature degradation are about 6.5 degrees Celsius higher than the actual temperature and have lost their monitoring significance. The temperature of the gallium arsenide sensor has hardly changed. It is still about 40 degrees Celsius, indicating that the temperature is in good condition and the bending resistance is stronger. The above methods are simple and easy to operate. Even in the project site without professional equipment, you can easily distinguish between the two sensors. That's all for today. Thanks for watching.